Okay, so today's deep dive is all about tackling one of the biggest headaches in AI. I'm talking about all that critical data just locked inside visual document.
Exactly. Things like PDFs, charts, scan contracts.
Stuff that most AI systems, frankly, just can't read properly. But our sources today lay out a path to getting really accurate search with surprisingly small, commercially ready models.
And it all comes down to the problem with standard RGA retrieval augmented generation. It's fundamentally text only.
Right.
And that creates this massive reliability gap. You get these high confidence hallucinations because the key piece of info might be in a chart or a diagram, something visual.
So multimodal RA is the fix. It combines a retriever with a vision language model, a VLM.
Yeah, and that VLM doesn't just see the image and read the text separately. It understands the relationship between them. That's the key to getting a grounded answer.
And the specific tools we're unpacking are two new, really compact Llama-Nemotron models built for exactly this.
It's a fascinating approach. It's this two-stage, 1 billion parameter system. First up, you have the Llama-Nemotron-Embed VL-1B V2.
Of a mouthful.
It is, but what it does is simple. It's a dense, single-vector embedding model. It's built for super-fast page-level retrieval.
And critically, it's compatible with basically all standard vector databases, right?
All of them. That means you're getting millisecond latency search, which is essential at enterprise scale.
Speed and compatibility are great, but the real magic usually happens in the refinement stage.
Exactly. That's where the second model comes in, the Llama-Nemotron Re-Rank VL-1B V2.
So a re-ranker.
Right. It's a cross-encoder. It takes the top few results from the embedder and then does a much deeper, more nuanced relevance check. It reorders everything so the absolute best evidence is right at the top.
Okay, but here's the question. Both of these models are small. I mean, about 1.7 billion parameters combined. Are we sacrificing real contextual understanding for speed and deployability? What's the trade-off?
That's the amazing part. The trade-off is minimal, but the benefit is massive.
Yeah.
Because they're so compact, you can run them on standard GPU resources. No huge operational costs.
And they're not just bloating the context window.
Not at all. They boost accuracy by grounding the AI on just better evidence from the start.
And that grounding, it really shows up in the numbers. Let's talk benchmarks.
For sure. If you look at recall at 5SO, finding the right page in the top 5 results, this combo hits 77.64% accuracy on tough image and text datasets.
And the re-ranker alone gives a pretty big lift.
A huge lift. We're seeing a solid 6 to 7% improvement in retrieval accuracy just by adding that second step.
You know, for an analyst who's buried in quarterly reports, that jump from around 70% to over 77% isn't just a number. That's the difference between certainty and having to do a manual check.
It absolutely is. And the business case is crystal clear. You have other models like, say, Giant Re-Ranker and Zero, which performs well but has a restrictive license.
Non-commercial?
Right. The Nemotron models have a permissive commercial license. That makes them perfect for any company needing a solution they can deploy right now.
So connecting this to the real world, where are we seeing this system actually solve problems?
Well, a great example is ServiceNow. They're using this for their chat with PDF features.
Yeah.
The Re-Ranker helps maintain coherent conversations over these huge, dense documents.
Bringing the most relevant page forward every time.
Every single time. Then you have IBM Storage, dealing with highly technical manuals.
Lots of diagrams, I imagine.
Exactly. They treat every page as a full multimodal document. The Re-Ranker makes sure that when it finds a domain-specific term, it's in the right visual context before it even gets to the LLM. It just dramatically improves how the AI reasons over complex stuff.
So the big takeaway here seems to be that visual aura isn't just for massive experimental systems anymore.
Not at all.
We've got small, deployable models that solve this long-standing problem of ignoring visual data, and they plug right into the infrastructure companies already have.
It really just fundamentally shifts the quality of AI reasoning over complex corporate data. And it leaves you with a critical question moving forward.
Which is?
If even 1.7 billion parameter models can get this level of enterprise-ready visual understanding, how quickly will multimodal capabilities stop being a nice-to-have and just become the absolute minimum requirement for any intelligent document system you build? Something for you to think about.